Here is 6. 6 minus a minus 2 is 8. And 10 minus 6 is 4. So these are all over the place. 0, 8, 4. It doesn't look like this is a quadratic or linear. The answer is going to be there exactly. So yeah, once again, the answer was C. So better luck next time. Okay, let's go. We're moving on now. There are three forms of a quadratic equation. Standard form, y equals ax squared plus bx plus c. Vertex form, y equals a x minus h squared plus k. And factor form, y equals a times x minus 3 times x minus s. All three of these forms were introduced to you in grade 10. Mandatory, of course. It's prereq for this. Once again, it may have been a while for some of you. So, what is standard form? Standard form is written as follows: y equals ax squared plus bx plus c, where a, b, and c are, give me 1 second. A, b, and c are coefficients, meaning they're just numbers. Here's some standard form examples. When a is positive, meaning the first letter here that's next to the x squared value, when a is positive, the parabola is set to open up. It looks like a U. When a is negative, the parabola is set to open down. It looks like an upside down view. So we have 2x squared minus 3x minus 1. This is the example. A is positive 2 in this example. And the second example, where you have the blue graph, a is negative 3 here. And you can see what effect the negative sign has on the shape of the graph, or the direction rather. C corresponds to the y-intercept. So hopefully you remember what the y-intercept is. It's when the function or the graph intersects or crosses paths with the y-axis. The y-axis, if you forgot, is the vertical axis. It's the one that goes up and down here. So here the C value is -1. And this is exactly where the graph goes, -1. Okay, Baba, here, go give it to Mama. Okay, then go to. So no orange then, okay, baby. All right, so the C value here is -1, so the y-axis is the y-intercept is there. In this example, the C value is +3, and the graph intersects the y-axis at 3. Okay. And here we have vertex form. So just to recap, standard form helps you with the shape of the graph. The A value helps you indicate whether it's a normal upwards facing U or upside down U. And then the C value tells you the y-intercept. The vertex form, however, tells you different things. So the vertex form lets us know A indicates the stretch or compression factor. Also indicates the parabola will open up or down. So it's the same A value. So A, whether it's in standard form or vertex form, kind of does the same thing in that it tells us whether it's opening up or opening down. But in vertex form, it adds an extra layer and tells you how stretched or compressed the graph is. H is the horizontal translation, or how far the graph has moved left or right. And K is the vertical translation, meaning how far the graph has been moved up or down. I'll show you examples of that right now. Excuse me. So here we have the vertex is located at HK. So H being the value inside the graph, inside the brackets, apologies, and K being the value at the end here. So H in this example is +1. That's actually a trick. If you remember, if you don't remember. If you look at the original equation, y equals a brackets x minus h, the h value is being subtracted from the x value here. So when you have a situation like that, and your equation is x plus 1, what does my h value actually have to be? Well, if h is 1, let's say, then the equation should look like x minus 1. Because if I put in a value of 1 for h, if I substitute 1 here, it'll be x minus 1. But that's not what's written here. X plus 1 is written here. So I know my h value cannot be just 1. Because that's not what's happening here. This is a plus 1. So what if my h value is negative 1? If I substitute negative 1 here into here, if I plugged in, let's say, negative 1, now I'm going to have minus 1, and that will change it to a plus 1. So what you need to understand is your h value is a little bit tricky, and whatever is written in the equation is actually the opposite sign for your h value. So in this case, my h value is not positive 1, it's negative 1. And h value is the horizontal movement, meaning it tells us whether the graph has been moved left or right. In this case, since h is negative 1, the negative direction on a graph is the left direction. And if you can't figure that out, it's very easy. 0 is in the middle, and to the left of 0 you have negatives, and to the right of 0 you have positives. So pretty straightforward. Left is negative, h is negative, so this graph has been shifted to the left by exactly 1 unit. And k is pretty straightforward. K is just as is, so if k is negative, that means it's moving up or down. If it's negative, it's moving down. So in this case, it's moving down 3 units. So the vertex, which I haven't mentioned, but hopefully you should know, is this point right here. It's exactly the point that's either the highest or lowest point in a quadratic. It's like the exact central point right in the middle there. So that is my vertex point, and that is given by the values of h and k. So what do I mean by that? Well, h is negative 1, so here's negative 1, and k is negative 3, and here's negative 3. So I make a point between negative 1 and negative 3, that's exactly where the vertex is going to be. And on this side here, we have negative. You know what? Maybe I'll zoom in a bit so you guys can see it better. All right, so zoomed in a little bit more. Hopefully you guys can see it clearer. Here my h value is, so in the equation it says x minus 3, but the actual value for h is positive 3. Remember, it's always opposite whatever's written in the equation there, the formula. And my k value is pretty straightforward, it's just 1. So if I make a point at 3 and 1, and if you haven't figured it out, h is your x value and k is your y value. Remember, x is left and right, y is up and down. So if x is 3, that's over here. If k is 1, that's over here. If I make a point, it's going to be exactly here. That's where the vertex is. So this is why this is called the vertex form, because it gives you the exact coordinates of the vertex. And we take a note that a is negative, meaning it's facing down, or it's opening down. So that's vertex form. Practice. We're going to practice with vertex form. Describe the transformations that have been applied to the parabola. I'm going to do this so you guys can just pay attention. So how do you describe transformations? Easy. The very first step is to write down your values of a, h, and k. We're running out of time. Normally I ask the class to do this, but it's fine. I'll be quick. A is negative 3. H is not negative 2. Once again, it's positive 2. And then k is negative 4. How do you describe the transformations? Boom. This is how you describe them. Vertical stretch by a factor of 3. That's from your a value. So a stretches the graph, and it's a vertical reflection. Reflection meaning that negative value, it's upside down. That's what it means. So these 2 points come from your a value. Your h value is very simple. Shift left 2 units. And your k value is very simple. Shift down 4 units. That's it. You can write horizontal translation to the left 2 units or vertical translation down 4 units. That's fine too, but most students, I think, prefer this. So just a reminder, your A value gave me 2 points of transformations, and your K and H and K just gave me 1. So yeah, that's how you do this. Here we have graph the parabola, y equals x squared. So let me teach you how to graph. Pretty straightforward. You have to pick points. I'll give you hints. The point in the middle is going to be your h and k values. H and k values are always the points in the middle here. And in this case, in this quadratic, what are my h and k values? Well, there are no values. There's no a, h, or k. So it's just going to be 0 and 0. And now you focus on the x values first by picking points above and below. That's it. So go up 1, up 2, and then up, down 1, down 2. To get your y values, just plug in the x values into the equation. So x is now 2. 2 squared is 4. In this example, x is 1. 1 squared is 1. 0 squared is obviously 0. Negative 1 squared is, well, what's negative 1 times negative 1? I'm just going to be quick here because we're running out of time. It is just 1. And then negative 2 squared is also 4. And you notice that there should be some symmetry in a quadratic formula or quadratic function. Sorry. So we're going to graph now. 0, 0 is my first point. 1 and 1 is my next point. And then 2 and 4 is over here. And here we have negative 1 on the x-axis and positive 1 on the y-axis. And negative 2 here and then positive 4 here. So this is what the graph will look like. Obviously, yours should be a little bit more neater. It's a bit harder for me to do this with a mouse. But yeah, that's how you do it. Let's keep going. Let's keep graphing. Where are we? Here we go. Graph the parabola. So the first thing you always do is write your A, H, and K values. In this case, A is the value in front here, but there is no number here. So very important to note, when there is no quote-unquote A value, you can't see it. It's actually an invisible 1. There is an invisible 1 there. It's just that whenever you multiply something by 1, it doesn't change anything, so that's why we don't write it. All right. So H value in this case, once again, H is not 5. I don't know how many times I have to mention this. H is the opposite sign of what's written in the formula there. And K is very simple. It is negative 4. So how do you start with this? You always start with a table of values. X and Y. You know that your middle point, you should always have 5 points. I should mention that. So 1, 2, 3, 4, and then 5 on the bottom there. Your middle central points are always going to be your H and K values. So negative 5 and negative 4. That is your vertex. Then you're going to take values above and below. So above, like +1 and then +2 and -1, -2. Now there's a few ways to do this. I'm going to teach you one of the ways. If you learn another way, that's fine too. So one of the ways is to just now plug in the value, x value, into the equation there. So if I plug in -3 here, Negative 3 plus 5 is y